Hello everyone, welcome to today's lesson on probability trees. So this is lesson 2 on this one. Okay, so last lesson, if you've watched the video, which you should have, it was just on creating probability trees and also like figuring out what the outcomes were going to be as well. So today we're going to concentrate on expanding on that a little bit, building on that last lesson and actually calculating some probabilities as well. So answering just a couple of questions using that information. Okay. So the starter for today's lesson, all right, is something that we need to be able to do today, right? So I just wanted to press pause, have a go at these, press play when you're ready. Okay, welcome back then. So hopefully you remember from previous lessons how to do this, and especially if you've watched yesterday's video because it did come up. Okay, so when we multiply any fractions, we always just multiply the numerators together and the denominators together. Okay, so we don't need to worry about when we're multiplying, we don't need to worry about the denominators being the same. Okay, that only applies for adding or subtracting. So for the first one, 1 times 3 is 3, 5 times 5 is 25, so the answer is 3 over 25. Okay, hopefully then, I'm not going to write the whole thing out for the others. Okay, 3 times 1 is 3, 4 times 3 is 12, but hopefully on that one, you've simplified it to 1 over 4, okay, by dividing by 3. For this one then, we get 2 over, and then 8 times 9 is 72. Well, that can be simplified as well to 1 over 36. And then for the last one, 90 over 121, which I don't believe can be simplified. Okay, so that's going to be important for today's lesson, multiplying fractions together. Okay, put that in examples, then copy this one down, press play when you're ready to go through the answers. Okay, so similar sort of question now to what we were looking at in last lesson, but it says here, look, draw a tree diagram and calculate the probability I get at least 1, 3 when I spin both spinners. So there's a little bit extra. Okay, yesterday, or last lesson, sorry, we were doing drawing the tree diagram and listing the possibilities, but that was it. So we still need to do those two things, but then we need to do this question afterwards as well. And what I would advise you do is draw the tree diagram and list all the outcomes and the possibilities before you even bother looking at what the question's actually asking you for. Okay, so let's do what we did then. So 2 square spinners with the numbers 1, 2, 3, and 4 on there, and we're going to be spinning each one. Okay, so we're going to do the first spinner. Okay, and the question is talking about getting a 3. So when we do our 2 different branches now, okay, we're talking about getting a 3 or not getting a 3. That's our possibilities in there. We're either going to get a 3 or we're not going to get a 3. Okay. Then for the second spinner, should be exactly the same thing, shouldn't it? Whether we get a 3 the first time or whether we don't get a 3 the first time, it doesn't affect what we're doing the second time. Okay, so we're still either getting a 3 or we're not getting a 3. And this is I'm only doing it this way because the question is asking about us getting a 3. If this said I get at least 1, 2, instead, then we would do 2 and not 2 and then so on. Okay, so we've got our diagram there anyway. Now let's fill the probabilities out on each branch. So on the first spinner, okay, it says there's the numbers 1, 2, 3, and 4. Okay, well the probability of getting a 3 then, there's only 1 3, isn't it? Out of 4, so there should be a 1 in 4 chance of getting that. Okay, the probability of not getting a 3 then, well, that's either by counting the 1, the 2, and the 4, which makes 3, doesn't it? Or just by remembering that each pair of branches together, each set of branches together needs to add up to 1. So if there's a 1 in 4 chance of getting a 3, there must be a 3 in 4 chance of not getting a 3. Okay, then the second spinner has got all the same numbers on there, so the probabilities are exactly the same. Okay, so 1 over 4 and 3 over 4, 1 over 4 and 3 over 4. Okay, so that's what we did last lesson anyway. Now let's list the outcomes by following the branches again. So the first outcome is that we get a number 3 on both. Okay, there's a 1 out of 4 chance of getting a 3 on the first one, 1 out of 4 chance of getting a 3 on the second one, and remember we multiplied, don't we? Okay, so that's 1 out of 16. Now we do the next possibility. So 3 on the first spinner, not a 3 on the second. So that would be 1 over 4 multiplied by 3 over 4, which is 3 over 16. Okay, then the next one. So we've done the 2 possibilities for getting a 3 on the first one. Look, Now it's not getting a 3 on the first one. So not getting a 3 and then getting a 3 is 3 over 4 times by 1 over 4. Okay, so again, that's 3 over 16. And the last possibility now is not getting a 3 on either spinner. So not getting a 3 the first time and not getting a 3 the second time. And that's 3 over 4 times by 3 over 4, which is 9 over 16. Okay, and remember, we want these 4 possibilities at the end to add up to 1 because these are the only 4 things that can happen. Okay, they do add up to 1 because they add up to 16 out of 16, don't they? So that's similar to what we did last lesson. Okay, and now the one added step is calculate the probability that I get at least 1, 3. So if we look at these 4 outcomes now, okay, we want to figure out which ones say that we get at least 1, 3. So at least 1, 3, I put it in bold, okay, because the wording can catch you out in the question, so you need to be careful. At least 1, 3 means any outcome where we've got at least 1, 3, okay? So this one would apply, okay, that one would work because that's getting 2 3s, so that's at least 1, isn't it? This one would apply as well because that's 1, 3 and then not a 3, so that one would work. And this one would apply as well because that's not a 3 the first time but a 3 the second time, so that's at least 1. Okay, so the only one this doesn't apply to is the bottom one. So you've got 2 choices now when you're doing your probability. Okay, we're going to do capital P. Okay, so hopefully you've seen this before, capital P, and then in brackets, okay, I'm going to write at least 1, 3. Okay, and now you've got 2 choices. We can either add up these 3 fractions that I've ticked, or we can take this fraction away from 16, away from 1. Okay, either way we're going to get the same answer, aren't we? So it should be 7 out of 16. Okay, because 1 plus 3 is 4 plus another 3 is 7, or 16 take away 9 is still 7. Okay, so we filled the diagram out, we've listed the possibilities and the outcomes, and then it's just about using that information, so using those answers to actually answer the question. So the probability of at least getting 1, 3 would be 7 out of 16. Okay, so similar to last time, I'm going to do one more example with you as well, and I'll give you some to have a go at yourself. Okay, so for this one then, Terry has 7 pens in a box. 2 of the pens are blue and 5 of them are red. Terry takes a pen from the box at random, writes down the colour and puts the pen back in the box. Then she takes another pen from the box at random, okay? Draw a tree diagram and calculate the probability that Terry gets exactly 1 pen of each colour. Okay, so let's not worry too much about the question at the moment. Let's do the tree diagram, okay? So she's picking out twice. So on the first pick, okay, the pens in the box are either blue or they're red. So she can get blue or red, can't she? All right. On the second pick, they're still blue or red. Okay, so that's what it should look like there. And this is for the second pick. All right. Now we'll fill the information out. So we need to fill out the probability. So having a look, okay, it says here that out of the 7 pens that are in a box, 2 of the pens are blue. Okay, that doesn't mean that you write 2 on here, which is a common mistake. It can't be 2, remember, because probability has to add up to 1, doesn't it? It can never be bigger than 1. So there's no way that that's 2. Okay, it's the probability of getting a blue one. That's what we're talking about on these branches, isn't it? The probability goes on the branches. So the probability of getting a blue, okay, is actually 2 out of 7, isn't it? Because there's 2 blue pens out of 7 in total. So that should be 2 out of 7. Which means then the probability of getting a red one should be 5 out of 7. Okay, because there were 5 red pens out of 7 in total. On the second pick then, because it says she writes down the colour and puts the pen back in the box, is no different the second time. So on the second pick, still 2 out of 7 for blue, 5 out of 7 for red. Okay, then we go through and list the outcomes. So the first outcome is she gets a blue on both picks, which would be 2 over 7 times by 2 over 7. So that is 4 over 49, okay? 2 out of 7 there, 2 out of 7 there, multiply them together. The next possibility then is blue on the first pick and red on the second pick. So blue, then red, that's 2 out of 7 for blue, 5 out of 7 for red, so 10 out of 49, because remember we're multiplying, we're going across the branches. Okay, so that's the possibilities by picking a blue first. Now by picking a red first, it would be red, then blue. So red in the first pick, blue in the second pick. So that's 5 out of 7 times by 2 out of 7. That's 10 over 49 again. And then the last possibility is getting a red on both picks. So red in the first one and red in the second one. So that's 5 over 7. Oops. Times by 5 over 7, okay, which is 25 over 49. And again, just double check that they add up to 49, okay, so you get 25, 35, 45 plus another 4 there, which is 49. Okay, so now we can actually answer the question. We've got all our outcomes. So that question says the probability that Terry gets exactly 1 pen of each color. So I'm going to write capital P, 1 pen of each color, right? So here, 1 pen of each color means this outcome here, okay, because that's 1 of each, isn't it? And this outcome here, because that's 1 of each. So it's those two there. This one doesn't apply because that's not 1 of each color, is it? That's 2 blues. And this one doesn't apply because that's 2 reds. So the 2 that apply is either getting a blue first and then a red, because that's 1 of each, or by getting a red first and then a blue, because that's still 1 of each. Okay, so these two together is 20 over 49. Okay, so again, make sure you've got the examples copied down to refer back to if you need to, and I'll show you the main task shortly where you can have a go at some of these yourself. Okay, so here's the main task then that I want you to do. Okay, so only 3 questions. So remember, read the information, draw the tree diagram first, fill out all the possible outcomes, okay, and then look at what the question's actually asking you for, okay? So press pause, have a go, and press play when you're ready to go through the answers. Okay, welcome back then. So I'll go through each one step by step, okay, to make sure that we're all clear on what we're doing. All right, so the first one then, there are 10 books on the shelf in the library, 7 of them are fiction and 3 of them are non-fiction. Draw a tree diagram and calculate the probability that if 2 books are taken, they are both non-fiction. Okay, so this is the first pick, or first book, whatever you want to call it. Okay, it's either fiction or non-fiction. Okay, when a second book is taken, then it's still either fiction or non-fiction. Okay, and that doesn't depend at all on the first part, does it? So what happens in the first pick doesn't have an effect on the second pick. So fiction, look, it says 7 of the books are fiction. So similar to one of the examples earlier on, that doesn't mean we write 7 on here because these branches are representing the probability, remember. So there are 7 fiction books out of 10 in total. So this should be 7 out of 10, okay? That means that's 3 out of 10. Okay, it tells you there that there's 3 anyway that are non-fiction, but also you know it's 3 because they've got to add up to 10 out of 10, which would make 1, wouldn't it? So all the same outcomes now on the second branches as well. So 7 out of 10 for fiction, 3 out of 10 for non-fiction. Okay, then from there we list our outcomes. So the first possibility is a fiction book the first time, fiction the first time, and fiction the second time. Okay, so that would be the probability of fiction is 7 out of 10. The probability of fiction is 7 out of 10. Multiply them together. Okay, so that would give you 49 out of 100. The next possibility is fiction first and non-fiction afterwards. So fiction, non-fiction, that's 7 tenths multiplied by 3 tenths, which is 21 over 100. Okay, so they're the possibilities of fiction the first time. Now on to non-fiction. So non-fiction and then fiction, that's 3 tenths times by 7 tenths. That's 21 over 100. And the last possibility then is non-fiction both times. Okay, so 2 non-fiction books would be 3 tenths times by 3 tenths, which is 9 over 100. Okay, and again, double check the answers. They add up to 100, so we're good to go. right? So far we've drawn the tree diagram and listed the outcomes. So then it says, calculate the probability that if two books are taken, they are both non-fiction, okay? Well, there's only one possibility where they're both non-fiction, and that's this bottom one here, look. So our answer is... Our answer is the non-fiction, okay? So probability of non-fiction is 9 out of 100. Sorry if you heard that. Mr. Tammy came in and interrupted me, but never mind. We'll let him off. Okay, so 9 out of 100 for that one. All right. So next question. So this one is talking about the box of sweets. All right. So box of sweets. 10 sweets contain 6 red. The rest are green. Draw a tree diagram. Calculate the probability of picking 2 sweets of the same color. So it's 2 different picks. Okay. So this is representing the first pick. On the first pick, it's either red or green. On the second pick, it's still either red or green, isn't it? Okay, so that's the second pick. From there, we fill the information out. Okay, so there are 10 sweets and 6 of them are red. Right, so again, we don't just write 6 on the red part, do we? We write 6 out of 10. Then it says the rest are green, so it doesn't actually tell you the number of green, but it's easy to figure out, isn't it? If there's 10 in total and 6 of them are red, then the rest of them that are green, that must be 4, because they've got to add up to 10, haven't they? So same on all of these as well. Then we list the outcomes, okay? So we can get red and red together, which is 6 over 10 times by 6 over 10, which is 36 over 100, okay? Red then green, 6 tenths multiplied by 4 tenths, okay, that's 24 over 100. Green then red, that's 4 tenths times 6 tenths, 24 over 100. And then the last possibility is green and green, which is 4 tenths times by 4 tenths, which is 16 over 100. Okay, add these numbers up now, makes 100 out of 100, so we're good to answer the question. So the question said the probability of getting 2 sweets that are the same color. Okay, so this option here, that's 2 sweets of the same color, so that one applies. Okay, this one doesn't because they're different. This one doesn't because they're different. This one does because they're the same. Okay, so the 2 outcomes that we can use are those 2 there, so we're just going to add those 2 together now. Okay, so 36 over 100 plus 16 over 100 is 52 over 100. So the probability of getting 2 sweets of the same color is 52 over 100. Okay. And last one then for the main task. Okay, a fair 6-sided dice is rolled twice. Draw a tree diagram and calculate the probability of rolling at least 1 5. So before we worry about question, let's do the diagram. Okay, so this is the first roll. And we're talking about whether or not we're getting a 5, okay, in the question. So that means we're getting a 5 or we're not getting a 5. Okay, that's what I would put on there. So then, say for the second set, it's either a 5 or it's not a 5. And then it's either a 5 or it's not a 5. Okay, and obviously this is the second roll. Now, same as before, we do the outcomes. So we do the probabilities on each branch. So a fair 6-sided dice, okay, we're talking about rolling a 5. Well, there's only 1 5 on the dice, and it's 6-sided. So that's 1 out of 6, okay? Meaning that should be 5 out of 6. Exactly the same now on the next set of branches too. Okay, then we do our outcomes. So we can get a 5 and a 5. 1/6 times 1/6, 1 over 36. Okay, we can get a 5 and then not a 5, which is 1/6 times 5/6, which is 5 over 36. Okay, then not a 5 and a 5, that'll be 5/6 times by 1/6, again 5 over 36. And the last possibility is not getting a 5 both times, which is 5 over 6 times 5 over 6, which is 25 over 36. Okay, so there are our outcomes. We're talking about 36s this time. Add those up, they make 36. Let's calculate now. Okay, so it says the probability of rolling at least 1 5. So anything with at least 1 5 in it. Okay, at least 1 5. So if we look at the possibilities now, the first option, that's got at least 1 5 in there, that counts. This one's got at least 1 5 in there. This one's got at least 1 5 in there. This is the only one that doesn't. Okay, so that one doesn't apply. All right, so we either add up those three that apply, or we take this one away from 36. Okay, either way around, we should get 11 out of 36. Okay, so that is how you would answer that question. Okay, remember you can pause at any time in the video if you need a little bit longer to go through the answers, but when you're ready, let's do the checking question now. Okay, so I've started the diagram for you. So read the question carefully, have a go, and then press play when you're ready to go through it. Okay, welcome back. So for this question then, all right, let's just fill the information out first of all. So a bag contains 7 green and 3 yellow balls. Okay, that's why we've got green and yellow here. So this is the first pick, all right, and this is the second pick. So on the first pick, okay, when a ball is taken out of the bag, all right, it can either be green or it can be yellow. It tells you in the question here, look, doesn't it? There are 7 green balls, but remember, that's not the number 7 on here. It can't be bigger than 1, can it? We're talking about probability on this branch. So there are 7 green balls, okay, out of, there's 10 in total, isn't there? Because if there's 7 green and 3 yellow, that's 10 in total. That means the yellow must be 3 out of 10, okay? But this is really important in this question. It says that after the ball is taken the first time, it's not replaced the second time, okay? So what I should tell you is, for every one of these probabilities now, it's not going to be out of 10 anymore. It's going to be out of 9. Because whatever has happened here, okay, whether we've taken a green or yellow the first time, that ball has not been put back into the bag. So when you do the second pick then, there's only 9 balls to choose from because you've taken one out on the first pick, okay? The numerators now, okay, this is what we call dependent probability, because what we write on these second set of branches will depend on what happened the first time, okay? So if we follow these branches now, all right, this says that we've picked the green one the first time. So if we pick the green one the first time, all right, there's 1 less ball in the bag now, which is why that's 9, but there's 1 less green, isn't it? Because we've just picked one of these greens out and we've kept it. So there's not 7 greens anymore, okay? There's only 6. All right. Remember now, each of these need to add up to 1, don't they? So if that's a 6 out of 9 chance of getting a green, then that's a 3 out of 9 chance of getting a yellow. And hopefully that makes sense because there were 3 yellows to start with. And in our first pick, we picked a green, didn't we? So that means there's still 3 yellows in there. All right. Let's go down to this one now. All right. So this one is saying that the first pick was yellow. So if we pick the yellow one the first time, okay, this would still be 7 greens because this is saying we've picked the yellow first. There were 7 greens to start with. So there should still be 7 greens because we've picked the yellow on this branch. So that's 7 out of 9. Okay, so 2 ways to work this out now. Either do is 2 over 9 because these two we need to add up to 9, or because if there were 3 yellows to start with and we've just picked one of them out, there has to be 1 less, doesn't there? So it's slightly different how you figure that part out, but then after that, listing the outcomes is also done in the same way. So green and green, just follow the branches. That would be 7 tenths times by 6 ninths. Okay, so 7 sixes are 42, 10 times 9 is 90. Green then yellow, so follow the branches. Look, green is 7 tenths, yellow is 3 ninths, so 7 tenths, oops, multiplied by 3 ninths is 21 over 90. Then yellow first, green second is 3 tenths times by 7 ninths. 21 over 90, and the last one is yellow first, yellow second. So 3/10 times by 2/9, 6 over 90. Okay, and if we add those up, we should get 90. Okay, then the question says, calculate the probability that both balls selected are different colors. So probability, and then I'm saying different colors. So anything where the colors are different, look, so this one doesn't apply because they're the same. This one applies because that's two different colors. This one applies because that's two different colors. And this one doesn't because that's two colors are the same. So that would be 42 over 90. Okay, so all to do with fractions in that lesson. All right, so still fill the diagrams out in the same way, list the outcomes in the same way, then use those outcomes to answer the question afterwards. Be careful of the wording in the question. So thank you very much. See you soon.